Today we're going to learn how to solve quadratic equations by completing the square. You've already learned how to solve quadratics by factoring, so make sure that you know how to factor before you take on completing the square. So let's say we were asked to solve this equation by factoring. So I go through my normal steps. I multiply a times c. 1 times -5 gives me -5. I find factors of -5. In this case, there's only two options. And then I look for which factor pair adds to -6 so that I can create my factors. Well, since neither of these pairs add to -6, that means that this quadratic can't be factored. And that's really a problem if we're trying to solve by factoring. Well, I'm so glad to tell you that there is another way to solve quadratics that can't be factored. There's actually two more ways to solve quadratics that can't be factored, but today we're going to learn the one called completing the square. Completing the square comes from turning the main part of the equation into a perfect square so that I can use square roots to help me solve. So let's take a look at some of the steps involved in completing the square. First of all, I need to make sure my equation is in the right order. It needs to be in standard form before I can start completing the square. I have to also identify A, B, and C because they're going to help me out. When I'm using completing the square method, I need to make extra sure that A is equal to 1. If A is not equal to 1, completing the square cannot be used. So after I make sure that I'm in the right order and that A is 1, I need to take my constant to the other side. So I'm going to take C to the other side, in this case by adding 5. And now I only have my x terms on the left and my constant on the right. And that's exactly what I want it to look like before I take my next step. Now in the next step, B is going to be all important. That -6 is what's going to help me complete the square. I'm going to add to both sides B divided by 2 and then square that number. So in this case, -6 divided by 2 and then square that number. That's what I'm going to add to both sides. -6 divided by 2 is -3. -3 squared, remember -3 times -3 is a +9. So that's the number that I'm going to add to both sides to be able to complete the square. The reason it's called completing the square is because then I can factor the left-hand side and look what the factors are. If I factor that, I get identical factors, and that's exactly what we're looking for. X minus 3 times x minus 3, when I square that, right, or turn it into a square, means x minus 3 quantity squared, x minus 3 times itself. On the right-hand side, just as a side note, 5 plus 9 is where the 14 is coming from. Notice, too, that half of B is what's going in both factors. Now I'm going to zoom out a little bit so that we can have some space to finish this up. It looks like a long, complicated process. Once you've gone through this a couple of times, it's actually pretty simple. So this is a really great way to solve quadratics. Remember, to get rid of a square, I square root both sides. When I square root a square, they kind of cancel each other out and I'm just left with the x minus 3. On the right-hand side, when I take the square root of a number, especially in completing the square, remember to take into consideration both the positive and negative root. In this case, if it's asking for an exact answer, you can leave that number in square root form. It's not going to hurt us at all. To get x by itself, to isolate x, I needed to add 3 to both sides, and I'm going to put that whole number first in my answer. So I'm going to write my answer as 3 plus or minus the square root of 14. If it's asking me for an exact answer, I'm done. My two solutions, my two roots, come from the plus and the minus. 3 plus the square root of 14 and 3 minus the square root of 14. And those are my two roots. Let's take a look at another one. Make sure that you have those steps written down so that we can follow those same steps in our next example. So first things first, is my equation in the right order? Is A equal to 1? If that's the case, then I can start completing this square. So again, take C to the other side. I'm going to do that in this case by subtracting 16. Identify B. B in this equation is -8, so I'm going to add half of B, then squared, to both sides. So half of B is -4. I'm going to square that number to give me a positive 16, and that's what I'm adding to both sides. I'm going to simplify the right-hand side and write the left-hand side as my two factors. Remember, it's half of B that's going to go in both factors. I can rewrite that as a square, and I can square root both sides. Square rooting a square leaves me with just the x minus 4, and square root of 4 is positive and -2. When I add 4 to both sides, my two answers are going to come from 4 plus 2 and 4 minus 2. 4 plus 2 gives me 6, 4 minus 2 gives me 2. My two roots, or my two solutions, are 6 and 2. Since we're learning to complete the square to find roots for, or to find x-intercepts for our parabola, this parabola is going to have x-intercepts at 6 and 2. One more. What's wrong with this equation, and why can I not use completing the square on it? It's in the right order, but remember how we said A has to be equal to 1? Well, sometimes there is a way to get around that. I actually can divide every term here by 5. And then I get an equation where I can use completing the square. If you can't do that, I would highly recommend not using completing the square on that problem. So let's go through this one a little more quickly. We have everything in the right order, and A is equal to 1. Get C to the other side. Divide B in half and square it. Add that number to both sides. Simplify and factor. Square root both sides. Remember to use the positive and negative root. Isolate x. And solve. My solutions, or my roots, are 12 and -2. Write down any questions that you have. Please make sure that you've written down all examples. I will see you in class. Have a great day.